Good morning students. Today we are going to discuss about the topic of Fourier series. For having arbitrary period. Arbitrary period means when the period is not given in the form of pi. That means minus 2 to plus 2 or minus 1 to plus 1 or 0 to 4. If the interval for the arbitrary period is from a to b and the length of the interval will be a minus b and capital L which is used in the formula, this capital L is equal to b minus a by 2. The Fourier series for fx, if fx is defined on the arbitrary interval of a to b, the formula will be fx is equal to a naught by 2 plus summation n 1 to infinity an cos nx by L. Remember, this L is inside the angle cos n a n x cos n pi x by L and sin n pi x by L. And this is the formula for the arbitrary interval a naught, an and bn. Now let's take an example for the Fourier series of the function fx for the arbitrary interval of 2p. The lower limit is from minus p to upper limit is plus p. By comparing this minus p to plus p with the limit of minus l to plus l, we get the value of l as a p. If the problem is given in the interval of 0 to 2p, then we will compare it with 0 to 2l and the value of l will be according to the p. Suppose the problem is for 0 to 4, then the value of capital L is equal to 2. Suppose the value is from 0 to 6, then the capital L is having the value of 3. Fourier series for arbitrary interval is this, where fx is equal to a naught by 2 summation n 1 to infinity an cos n pi x by L, where L is inside the angle, plus bn sin n pi x by L. Now we are going to calculate the value of a naught for the given problem. Capital L, we calculated the capital L as a p. Putting the value of function fx and L in the formula, we get this value. Function is having 0 for the limit minus p to 0. Function is having a value of p minus x for the limit 0 to p. So finally we integrate this value. Integration of p is p into x minus x square by 2. Substituting the value lower limit and upper limit. Substituting the upper limit, we get this value. For lower limit, we get 0. Now finally the a naught will be equal to p by 2. Again we are going to calculate the value of an by putting the value of p and function in the given formula, where capital L is p and function is again having a two value 0 as well as p minus x. For 0 we have integration as a 0. For we are only going to calculate the value for 1 upon p integration 0 to p minus x cos n pi x by p. Again first, this is by using integration part, first and second part. First part is same, integration of cos n pi x by p is equal to sin n pi x by p upon n pi x, because we are integrating with respect to x, minus integration of p minus x, differentiation of p minus x, that means minus 1, and again same value sin n pi x by p upon sin n pi x by p, but again the integrating the sin n pi x by p, we get the value of minus cos n pi x by p, and the lower term is square. Now putting the value of upper limit p and lower value, lower limit 0, we get 1 upon p 0, p square by n square pi square cos n pi x minus 0 p square by n square pi square cos 0. Cos n pi x is equal to minus 1 to the power n and cos 0 is 1. Now we get the value of an. An is equal to p upon n square pi square 1 minus minus 1 to the power n. Suppose suppose n is equal to even 2, 4 and 6, then minus 1 to the power even is plus 1. So 1 minus 1 is 0. So finally an 4 and a1 is 0. Suppose n is odd. If n is odd, that is 1, 3, 5, then minus 1 to the power odd is minus, minus minus plus. So finally we have an is equal to 2 upon p n square pi square. Now we are going to calculate the value of Bn by substituting the values of P and the function in the Bn formula. We get, by putting the values of the Bn formula, we get Bn is equal to P upon n pi. Substituting the A naught, An and Bn in a Fourier series and expanding it with respect to the terms, we just have to expand the Fourier series up to 3 or 4 terms of the summation. Now these two questions you have to solve accordingly, where the lower limit is minus L to plus L. That means capital L is equal to 1 for the function first. For second function, minus L to plus L, period is 4 but capital L is equal to 2. You have to solve both the question and also prove the second one. Thank you. And please feel free to contact your subject teacher, because without discussion and without practice, mathematics is just impossible for anyone.